In problem 1, we're supposed to solve the equation for x. And so a first step that we could take is to distribute the 4 to the x minus 2 that are in parentheses. And so that gives us 4x minus 8, and then we bring down the plus 5 equals 17. Our next step is to combine our like terms, the negative 8 and positive 5. So that gives us 4x minus 3 is equal to 17. Then we would want to add 3 to both sides. And then finally, the last step to isolate x would be to divide both sides by 4. So that gives us our final answer of x is equal to 5. Sometimes it's a good idea to go back in and check your solution. So we can take that x value and plug it in where x is. And our goal is to see if that's equal to 17. So that would be 4 times 3 plus 5 is equal to 17. 12 plus 5 equals 17. And if we combine 12 and 5, that does give us the result of 17. We get the same thing on both sides of the equal sign, so that tells us that our solution checks out. On problem 2, our goal again is to solve for x. In this case, we're dealing with some fractions. Fractions all just represent division. So the best way to clear those fractions is to identify what the lowest common denominator is. In this case, it's 15. That's the smallest number that both 3 and 5 go into. And so our first step is going to be to multiply both sides of the equation by that lowest common denominator. We'll go ahead and put 15 over 1 on each side since we're multiplying the fractions. And when you multiply the fractions, you multiply the numerators together and the denominators together. So as we distribute that 15 to all parts of the equation, then we end up with 15 multiplying the numerators of all the fractions, and the 1 multiplying all the denominators of the fractions. Our next step, distribute the 15 to both sets of parentheses that are on the left side of the equation. That gives us 15x plus 30, and then 15x minus 60. And then the next step in order to completely clear those fractions is to go ahead and do the division that's shown. So with the first fraction, we'll divide the terms by 3. Second fraction, we'll divide the terms by 5. And then on the right-hand side of the equation, we'll divide 180 by 5. So when we divide 15x plus 30 by 3, the result of that is 15x plus 10. When we divide 15x in the next fraction by 5, we get 3x as a result. At this part, we have to be careful because we are subtracting a negative 60, which ends up turning into a positive value. And 60 divided by 5 gives us 12. And then on the other side of the equal sign, we're left with 36. This is just one way to organize how to solve this problem. There's other methods as well. So if you did it differently but ended up with this as your result, then you're still on the right track. From here, we want to solve the equation in a way that's similar to how we solved number 1. First, we'll combine our like terms. Then we'll subtract 22 from both sides. And our last step will be to use division in order to isolate the x. So our solution is x equals 7. On problem 3, our goal is to isolate the specified variable. In this case, we want to solve for x. That means that we need to cancel out everything that's around the x. We'll start with what's on the outside of the parentheses, which is the w. Since the w is multiplying the set of parentheses, we would cancel it out from that side by dividing both sides by w. That gives us t over w on the left-hand side and leaves us with x minus 2 on the right-hand side. Then we would just need to add 2 to both sides to finish isolating the x. So there's our final answer. On problem 4, some of you might still have a typo on your packet. It's asking us to solve for v, but there's no equal sign shown and the expression isn't set equal to anything. And so you can't solve for a variable unless there's an equal sign involved. And so we need to fix this by setting it equal to something. In this case, we're going to go ahead and set it equal to r. Now that we have an equation and we've got an equal sign that we can work on both sides of, we can go ahead and start trying to isolate the letter v. We want to start by getting rid of the divide by p by multiplying both sides by p. Our next step could be to cancel the u that's in front of the parentheses by using division. Then we would want to add 5 to both sides. And final step to isolate v would be to divide both sides by 8. And so this one, the answer looks somewhat complicated because there's a fraction within a fraction, but algebraically it's correct. On problem 5, we're asked to solve for x. A good way to start this problem is to first use the distributive property to get rid of the parentheses. So we'll go ahead and distribute the 3 to the first set of parentheses and the 2 to the second set of parentheses. That would give us 3x minus 12 plus 2x plus 10 is equal to negative 12. Next step is to combine like terms, giving us 5x minus 2 is equal to negative 12. Then we would need to add 2 to both sides. And the final step would be to divide both sides by 5. Giving us a final answer of x is equal to negative 2. On problem 6, we're asked to solve for x again. So the first step in order to isolate the x would be to add 9 to both sides of the equation. Next thing we would want to do is cancel the divide by 4. We can do that by multiplying both sides of the equation by 4. That leaves us with 1x is equal to 156, and that's our final solution.